Hi there, my name is Mark, and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array. This video details my results for January of 2024, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. This is a new year, and a new look for the presentation. I've also added some additional content which I hope you will think is useful. Here's a picture of our 16 kilowatt ground mount solar array. The solar array is directly south facing in one of our pastures, with no trees or other obstructions around it. We have 50Z and Shine panels, rated for 320 watts each, with Hoymiles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240-volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed. No time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using a Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. This is what the Sense app looks like, showing the statistics for the month, including solar production, usage, energy to the grid, and energy from the grid. January is firmly in the grip of winter, so it is expected that electricity consumption vastly exceeds the production. The fully blended cost for electricity in this month, including all taxes, fees, credits, would be 12.2 cents per kilowatt hour, which is about 9 pence per kilowatt hour for my UK viewers. Using this rate, the value of the solar production for this month was $56.31. The cost of my usage would have been $247.33 at this blended rate if I didn't have solar. Here's an overall look at the solar production for January 2024 by day. Total production for the month was 462.3 kilowatt hours, with the lowest day being 1.7 kilowatt hours on January 17th, and the highest being 47.6 kilowatt hours on January 14th. The overall average production per day was 14.9 kilowatt hours. The total amount of hours of sunlight per day went from 8.5 hours at the start of the month to 9.5 hours at the end of the month. Here's a comparison of the January 2022, 2023, and 2024 solar production. Since we now have 3 years of data to look at, it can be interesting to look for patterns. Nothing really sticks out as being especially significant this month, since there are always natural variations in the weather. As a way of comparison, the PVGIS website suggests that I should get 696 kilowatt hours at my location during this month. The weather was quite cloudy for most of the month. Here's some additional details for the highest solar production day, January 14, 2024. At my location, their sunrise was at 7:52 a.m. and sunset was at 4:42 p.m. for a total of 8.84 hours of daylight on this day. Highest 1-minute sampled solar production was 10.3 kilowatts at 11:46 a.m. Here is solar production and actual usage plotted together for the highest generation day of the month. The high spikes on the usage graph are from the electric furnace or the water heater turning on. Furnace was on for a little over 3 hours total, consuming 50 kilowatt hours of electricity by itself. The reason usage was so high was that the low temperature of the day was 15 degrees Fahrenheit or -9 degrees Celsius. Very cold for our part of the country and a very uncommon temperature. Here is solar production, overall usage, energy sent to the grid, and energy from the grid on a per-day basis for the month. Usage, in this case, is power used by the house, regardless of whether it came from the solar panels or not. The large block of from grid was when we had low temperatures in the range of 10 to 15 degrees Fahrenheit, which is -9 to -5 degrees Celsius. Here is the month-by-month comparison of the actual amount that I paid the power utility each month for 2022 through 2024. The minimum amount of my bill is $7.49, which is my connection or standing charge. Note that the billing cycle's start and end dates are in the middle of the month, so you can't compare the costs paid here with the kilowatt hours consumed. In January of 2024, I still has some credits left over from last year, which is why my actual electric cost was just the standing charge of $7.49. Here is the month-by-month comparison of solar production between 2022, 2023, and 2024, along with the yearly total solar production. It will be interesting to see how 2024 looks after June, since my array was offline for 3 weeks in 2023. Here is the month-by-month comparison of our usage between 2022, 2023, and 2024, along with the yearly total usage. I have almost no control over the solar production, but I have a lot of control over how much power is used. You can see that electricity usage was down about 1/3 from 2023 to 2024. Let's hope that trend continues. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video. Have a great solar day and see you next month.